Hello, my name is Pablo González and this is my colleague Fran Ramírez. We are proud to introduce the ATT&CK Adversary, Emulation and Offensive Techniques collaborative project. We are proud to be at activity this year. Besides, we like very much the offensive part and that's why we bring a tool called ATT&CK, which helps to perform the emulation of adversaries. Also, we want to tell you about the collaborative side of the project. First of all, let's introduce ourselves. I am Pablo González. I work at Telefónica in Spain in a pre-innovation department where we are very lucky to play with cybersecurity and artificial intelligence. We develop several open source tools a year and try to contribute with crazy ideas. I am MVP of Microsoft since 2017. I have written some books in Spanish about cybersecurity and I am a teacher at several universities in Spain. My partner Fran Ramírez works with me at Telefónica in the same pre-innovation department, focusing on cybersecurity and machine learning projects. He has worked several years in the USA as a system administrator and has written some books about Docker and machine learning. Before we discuss the tool and show the use cases, let's have a look at MITRE ATT&CK. The emulation of adversaries has become extremely important in the red team world. It's an exercise that provides a glimpse into the potential for a real threat, like many others that both business and society have experienced, to affect an organization. The goal is to be capable of verifying if the organization controls are efficient and effective by detecting the threats or displaying weakness in response to them. The purpose of a red team exercise are the following: demonstration of the exposure run risk level, demonstration of the business impact, demonstration of the prevention capabilities, demonstration of the detection capabilities, demonstration of the capabilities of reacting or addressing incidents. Now, we are going to speak about ATT&CK. MITRE ATT&CK is a database containing the most common techniques, tactics, and methods being used by attackers. Tactics are the high-level vectors of attack, and the techniques represent the implementation of methods of attack. The organizations can perform an adversarial emulation and keep mapping the security controls that are applied to the techniques. Organizations can also have several security controls related to a given technique. The goal is to verify the performance and efficiency as regards the security control by techniques implemented. The MITRE ATT&CK framework takes on the security breach. The starting point is the original intrusion tactic. Any activity that has been previously carried out will be covered by a framework called ATT&CK. Now let's find out more about ATT&PWN. ATT&PWN is a computer security tool designed to emulate adversaries. The tool aims to bring emulation of a real threat into closer contact with implementation based on the techniques and tactics from the MITRE ATT&CK framework. The goal is to simulate how a threat works in an intrusion scenario, where the threat has been successfully deployed. It's focused on Microsoft Windows systems through the use of the Powershell command line. This enables the different techniques based on MITRE ATT&CK to be applied. ATT&PWN is designed to allow the emulation of adversaries as for a red team exercise and to verify the effectiveness and efficiency of the organization control in the face of a real threat. What is the ATT&PWN core? Powershell. Okay. Powershell is released along with Microsoft Windows Vista. It's not natively embedded in the operating system, which made it very interesting for both IT administrator and pen testers. Its new version includes a large number of new features and modules that will help to integrate increasingly with the operating system and its menu tools. And first version was released in 26. The first stable version. Okay, two versions appeared in 29 with the release of Windows 7. Version 3 appeared in 2012 with the release of Windows 8, and later the last version, version 7, appeared in the year 2020. The idea underlying ATT&CK to link the MITRE ATT&CK framework along with the techniques that are implemented via the Microsoft Windows PowerShell command line. The many techniques implemented using PowerShell support a high percentage of techniques listed in the ATT&CK matrix that can be replicated. The project is also collaborative. It means that the user can have his initial knowledge base based on ATT&CK, but can import new implementations of the techniques used in PowerShell and relaunch them using the techniques and tactics identified. We have used JSON format files to export this new knowledge and import it in other environments where ATTPwn has been deployed. In this way, the cooperative knowledge has become very significant. This facilitates multiple users to share knowledge between several environments. The techniques are dynamic elements that are emerging through the evolution of offensive security. Now, my colleague Fran Ramírez is going to give you a little insight into ATTPwn.
Hello, everyone. First of all, I want to say that it is an honor for us to be again at the awesome activity for one more year. Okay, so now let's see what the architecture of ATTPwn looks like. ATTPwn has three main different components. The first one is the console. That is the PowerShell code that will be running on the Windows machines emulating the threat. After this code is executed on Windows machines, it connects towards a command and control, and it waits for the adversary's commands to be emulated. The second one are the functions. These are the technical implementations that are mapped in MITRE ATT&CK. This is interesting since any user can create their functions written in PowerShell. This makes ATTPwn collaborative and a project where any user can contribute with their knowledge in the form of technical implementations. All the functions will be carried out by the console when it is executed through Windows machines. And the last one is the command and control MVC or C2. This is the ATTPwn control panel. From this panel, you can set up the threat or adversary to be emulated. You can use already pre-set up threats, or you can build new threat or test. The tool's knowledge can be imported and exported from this panel since the user can create his content in the form of an implementation of a technique in PowerShell. In other words, a basic architecture scheme has two main elements from the networking point of view. The first is the agent or warrior. It's the adversarial emulation, and its code is in PowerShell. The second one is the root node or command and control. From this web application, it is possible to manage the application of the threat to be simulated by the different deployed warriors. Also, you can manage the results of the emulation and make decisions about the controls. Everything is fully connected with the identifiers of the ATT&CK matrix. Again, from the networking point of view, the deployment of warriors over the network will be accomplished through different options. Remote invocation through the network privilege, invocation of remote machine without privilege, local invocation, etc. It is recommendable not to include more than 10 or 15 computers in this process, as indicated by the ATT&CK. These exercises are simulation, but you must have a real as possible environment for better results. Okay, and now let's talk about the operational flows. These are the different flows between the console or agent and the ATTPwn command and control. The first flow is the connection flow. When a console is running on a Windows machine, it sends a hi command. When the console is running, it gathers information from the machine and then passes it on the control panel through this packet. During the warrior generation, the IP address to be connected must be specified. But this is discussed further below. When the warrior needs to register as a compromised computer, it sends a request through the HTTP post method of the root node, stating the warrior ID and the collected information from the computer. When this information is received by the root node, the data will be stored into the database and will be made available for the user. That is in order to assign the plan set in a thread and perform its execution. When all this information reaches the command and control, it saves the information into a database and sends an OK signal. The second flow refers to the adversarial planning and execution process. The console or agent will ask for information about the thread plan to be performed. If the user has not created a thread plan for that console, the answer will be no thread plan. When there is already a thread plan created for that console, an OK signal will be sent. Later, the console will start asking for the functions that are part of the thread plan. For each function downloaded and executed, the results will be reported to the command and control. In other words, when the warrior connects to ATTPwn, it requests a new thread plan through the getPlan function. If the user has assigned already any plan to the warrior, it answers OK, and the thread plan will be delivered. This plan is generated in a JSON format. More details about this file will be provided later. Once the thread plan is available for the warrior, it will perform the request of each function or task to be accomplished. This is made through the getTask function. A getTask function will be run for each technique implementation that the warrior requires to be performed in order to fulfill the thread plan. For each prior run, two values will be returned through the putResult function. The first one, whether or not the ATT&CK technique has been executed successfully. In the second case, we get the output from the function that implements the returned technique ready for a technical review that can check the results. Okay, and now the third flow is the sign out flow. After all the techniques have been performed, the communication closes and the thread emulation is finished. So the console will send the buy command. Therefore, the root node will also assume the warrior as dead if it does not report any activity for a long period of time. In the other side, the warrior will show activity if, before a thread plan is associated, the warrior is requesting a plan.
Now let's talk about some key elements in the ATT&CK to go a little deeper. The console will be created from the web application specifying the IP address from where the console file will be downloaded. There is a file called the console template that houses the instructions that will manage the connection, the thread plan, and the connection closure mentioned in the previous section. When the instruction provided is being executed on a Windows machine, the PowerShell code necessary to carry out the warrior instantiation will be launched. The console has two parts, with a large if in the middle. The first part of the basic starting path is the beginning of the thread. As seen in the previous section, a connection request shall be made. First, a unique ID is generated for this instance to be identified in the root node. Also, the information on the operating system where it's running is gathered. The second part is driven by a case that can happen in many thread emulations. The process where a privilege escalation or lateral movement to another machine produces a new privilege process, or one that can be executed in another environment, has been called splitting. In this case, the console will be invoked with an ID. That is, it will not have to generate the warrior ID that identifies the warrior to the root node. In other words, if there is a plan with 3 tasks and the second task is a privilege escalation and this one is successful, then the third task will be executed in another process at an operating system level. But from the ATT&CK logical point of view, it's the same warrior. That is, it inherits the same warrior ID. How do we define a thread? Simple, through a JSON file. The thread plan is generated in the root node according to the user's needs. The user can use real threads already created or build their threads and see the output of their monitoring techniques. The document format delivered with the plan is JSON.
Let's talk about how to create your ATT&CK functions using the skeleton function. Any user can create or add features to implement techniques from the MITRE ATT&CK. Each implemented function is linked to a technique and one or more tactics in the framework. The main components from the skeleton functions are the technique to be launched or the function and the main program. This main program will be in charge of managing the flow of the technique to be performed. And this main program is in charge of another 3 tasks. The first one is request the necessary data to the root node for the technique to be executed. This is an execution prerequisite. The second one is check if the execution of the technique has been successful or not. The output will be stored in a true-false variable. And the last one is there is some data collected, such as credentials dump, IP addresses, or user enumeration, that can be used by another technique because all this information will be dumped to a data store that has the root node. This scheme can be visualized in any of the functions that can be found in ATTPwn. ATTPwn is a collaborative project where the goal is to share knowledge through thread plans. For this reason, the tool allows exporting user-generated threads and importing them into other ATTPwn instances. During the thread plan generation or query, the export plan option can be used as shown in the image. Once the file is stored in JSON format, it can be shared with the community. The JSON file contains all the information needed to recreate the thread plan, with all the tasks and implementation of techniques involved, even if these are not available in the new scenario.
Now let's look at some use cases. In ATTPwn, you can execute the for or noun threads and the threads or adversaries that we create. With our custom threads, we can make our own version of a noun thread with ATT&CK techniques selected by us, create our own version of an attack with ATT&CK techniques, and perform an execution of a thread, noun or created by us, that implements our own functions through the skeleton function. In this section, we will perform different scenarios and explain them.
Okay, in this first demo, let's see what a warrior is. To do this, we will create the warrior in this option and copy the code that ATTPwn delivers to us. Then we go to the computer where we will make the adversary or thread test. Paste the code, it will be executed in a new PowerShell, and finally it connects with ATTPwn, downloading a console. If we go to Home section, we will be able to see the computer where the warrior is running. Here we have the architecture data, the process that it's running, the IP address to which it belongs, and the warrior's identifier. In the plan section, we have some predetermined threads, as we can see here, like WannaCry, NotPetya, Flame, Dark Comet, or Dooku. Let's select, for example, WannaCry, and here we can see the techniques and the ATT&CK tactic identifier that forms this version of WannaCry. We could use it against a warrior, launch the warrior plan, and finally execute it step by step, all those techniques that correspond to WannaCry in this case. In this second demo, we are going to gather information to verify that there are different techniques within ATT&CK and ATTPwn to be able to collect that information to recreate the malware threat. Next, we are going to do a privilege escalation technique that will split the ATTPwn console process in two. One without privilege and the new one with privilege. The first step will be to create the warrior, copy the code, go to the PowerShell, run the code, and finally obtain the warrior executed. Okay, now let's go to the plan option, create a new one, select the gathering tactic where we can see here, besides the implemented techniques, we also have the discovery tactic where we can see some ATT&CK techniques generated. In this case, we are simply going to make a selection of the processes that the machine has. We will add this technique, then we'll go to the escalation of privilege where we are going to use a bypass of USC technique named 1088. We add it, we put a name to the thread, and finally we will create the plan. Once we have the plan created, we can select it here. We see the elements of our plan with which MITRE tactics the mapping is performed. And we can identify the warrior over the warrior we want to launch it. And finally, we launch the plan. At this moment, the ATTPwn console will start working and it will read the plan, and here we have the pending task. If we go to the result option, we will see how the first technique has already been executed. Invoke get process, which is just a collection of processes. We can see success. If we refresh it or we wait for a little while, we will find that USC bypass has also been successful, and we really get a double process. The one of the left is without privilege, but the one on the right is a process in which instructions with privilege are being executed, but we had no more technique after the privilege elevation of execution. In the ATTPwn technical part, we can see the techniques output. We can check the processes that the computer has, and here we can also see the UAC bypass result. And here's the second demo. In this third demo, we are going to perform an escalation of privilege, but also a credentials dump. To do this, let's create a warrior pointing to the ATTPwn IP panel, copy the code and run it on the Powershell console as we see before. Here we can see the information about the new warrior connected to the panel, and now we are going to create a plan. The third plan will have a privilege escalation. We will use again 1088, that is the USC bypass. And we will execute a credential access tactic using a power dump, but we could also use Mimikatz to perform the credential dump. The interesting part is that once we get the privilege escalation working, we will get a new process with privilege, and this process will be able to perform the credential dump. Okay, so let's create the plan, deploy the threads, select the thread, select the warrior, and finally launch the plan. Okay, and now let's go to the ATTPwn output section, and here we'll be able to see the techniques or tasks pending execution. Like the 1088, if we give it a little time, we will see that it has been successful. This new process with privilege has not been created yet. We will see in the next phrase. Here we can see the console without privilege, and this second panel where we find the credentials dump still running. And now we can see that the power dump technique is finished. But where can we see the results? Like in the previous demo, here we can see the output that this technique has. In this case, the UAC bypass. While the second technique executed in this process, the credential dumping, has returned us all this information. This information is very important. As we see here, we have users, user ID, has LM, has NTLM. As I said, this information is very important because we will be able to use it through a data store. The data store can be used by techniques that are performed afterward. For example, a lateral movement technique can be used these hashes and these users because of this data store. This is a very, very important element within ATTPwn.
In this fourth demo, we will perform the following scenario. First, an escalation of relays. Second, credential dump or credential dumping. And finally, we will make a lateral movement from computer with Windows 7 to the computer with Windows 10. First, we are going to deploy a warrior on the Windows 7 machine. Okay, as we have done in previous demos, we type in the ATTPwn IP address and finally create the code. We copy the code from Powershell and run it on Windows 7. Okay, we copy the code from ATTPwn and run it on Windows 7 on PowerShell. Okay, once executed, we go to home and obtain as before the new warrior running Windows 7. Okay, well, now let's generate a plan where the first step is to execute this technique. For example, by the counts T1078. Okay. The second technique is an escalation of privilege, and third technique is credential dumping, and the fourth step or fourth technique will be a lateral movement. Okay, now insert plan and select a plan, new plan or new thread, and we assign warrior ID or ID warrior to new plan. Okay, and look at results view and we have a data store. Okay. These are techniques, several techniques about the new plan. And data store, we add an IP address to the data store. Okay. Okay, well, refresh the web page several times until the lateral movement is complete. The technique of lateral movement is complete. Now ATTPwn is still execute all process, and now refresh the web page several times until the lateral movement is complete. Okay, observe that we have an ATTPwn console running on Windows 10. Yeah. Then now we can conclude this demo form. Okay, now we are going to speech about demo 5. Well, in this fifth demo, we will work on all-in-one thread concept, where we will automate the service discovery and the discovery of machines within a network as a threat or an adversary could do. The data discovered will be stored on the data store by the technique being used. Then we will perform a privilege escalation, obtain a new privilege process on the Windows 7 machine. Then we will make a credential dump thanks to that privilege escalation, where we will acquire hashes and users. Then we will make a lateral move where we will use the hashes, users, and the IP addresses from the computers within the network to try to make that lateral move through the MITRE ATT&CK technique. In this way, the whole process is fully automatic, so we can test the effectiveness or efficiency of security controls within the organization. We will start, as always, by generating a warrior. In this case, we check the IP address again, copy the code, and go to Powershell to paste the code. Okay. Okay. In the home section, we will see the console connected soon. Here we see the data, and now we go to the plan section. Okay, waiting for the warrior. And we go to the plan section. We create a new plan, begin with discovery tactic using the ATT&CK technique, where this port scanning will allow us to discover computers. Okay, we add the technique to the plan, indicating an escalation of privilege, and then credential dump with power dump or mimikatz. And finally, the last technique, again, a lateral movement. Okay, and thread name, DEFCON demo 5, and all in one, and thread description, blah, blah. Okay, we put the name all in one, create a plan, and link it with the warrior. We go now to the results. Okay, well, first allocate plan, And now we go to the results. We see the console begins to work. Now we can see here the task to be done, and the scan begins. One moment here, yeah. The scan is a technique that eventually can take quite a long time, can be seconds or minutes. So we will speed up the demo a little bit so that this part goes as fast as possible. Okay, once the scan has finished, we will be able to check that it has been successful, and if we go to the data store. Okay, now we go to the data store, we will be able to see the computer IP addresses that are currently alive on the network. Right now, the second technique, that is the escalation of privilege, has also been successful, so the process has been unfolded, and right now the process dump credentials. Okay. If we refresh the page, we will see the credential dumping has been successful too, and if we go to the thread data store, we see that we have IP addresses, users, and hashes. These hashes can be edited from here directly, like any data from the data store, and the changes will be saved by clicking on the update record. Okay, for the thread to finish, we will have to check if the result is correct or not in the lateral movement. We must consider that these techniques are used to test the efficiency and effectiveness of the security controls within the organization. Therefore, certain implementations may be detect and avoid the execution of some codes. Okay, now a new process on Windows 10 has been implemented. There are no tasks, and we have performed the lateral movement. In other words, the thread has moved from Windows 7 to Windows 10, from one machine to another over the network. And we have also done the whole process of a thread that is real for us, detecting computers in the network, trying to escalate privilege, dumping and accessing information such as hashes, and finally a lateral move with one of the techniques that can be implemented within the lateral move tactics. In this sixth and final demo, we are going to export the thread plan and then import it into ATTPwn. To make a simple example, we can choose NotPetya, select the thread, get the techniques to use, and proceed with the plan export. In this button, we export this knowledge. If we want to share knowledge with other users, our thread knowledge that we already have created, or even techniques that we have implemented in PowerShell and added to ATTPwn, we could create any plan, set a name, create a plan, choose it, and proceed to export it. Okay. If we want to share this plan with another user, we will send him the JSON file which we are going to open to see the content. Okay, JSON, opening JSON file in Firefox. Okay. Okay, as you can see, even the function definition written in PowerShell exactly as we have created it, is transferred. So if we want to share this information with another user, we can export those plans containing the functions that we have created in PowerShell and add it to ATTPwn and send this JSON. Okay, it's very simple and collaborative way to provide the knowledge to other users with offensive techniques within the ATT&CK mapping. Well, this is the last demo, and I will pass the word on to my partner, Fran.
Okay, so that's all. Feel free to visit the ATTPwn GitHub and download the software. This is a new tool we are currently working on, and we are adding new techniques. Also, the project is collaborative and everyone can help the project grow. And now we are ready to answer any questions you may have about ATTPwn. Thanks a lot.